Okay, in theory, yep, we're live. I'm gonna check the audio. Let's see.
Okay.
Okay, yep, that was a little feedback loop. Okay. Day 18. Maybe I should announce the stream.
Couldn't hurt, yeah. Oh, is that when you do an alert, or was that automatic?
I used to have some automatic stuff, but they kind of broke. So now I just manually post in the Discord and sometimes Twitter.
Oh, I was wondering, I guess the thing that must be automatic is like in Twitch, I saw a little pop-up that's like, Jeff is streaming, come watch.
Oh, yeah, that's odd. I think if you follow and I think by default, if you follow somebody, you get those. But I don't know who actually listens to those. All right. 18, 19, 20. Yeah, there's only three left. Then we're done forever. Streaming anyway.
Oh, not forever.
Well, we'll say this series is done. Finished a whole season.
Season 1 of the Wanix show.
Yeah. Let's see. And still, so Monday we usually stream, but we didn't. There's GDC going on this week.
Oh yeah, are you doing anything?
A little, just catching up with people and going to other social things when I can.
Cool.
So yeah, plus I don't know, maybe it's better to stretch out these last ones, but again, it's almost ready for a demo release, but we'll save that for the last stream. Let's see, what are we gonna do today? Let's go over here. Well, I guess there's stuff that's happened. We had build issues that we figured out, sort of.
Did we?
No. I don't know why.
Well,
You're the only one who's had this issue. I mean, you can't be the only one that could have the issue, but so far you're the only one that has had the issue.
yeah.
But it's not really my fault per se. I don't know what's going on. Because it's network related or seemingly.
Yeah. I guess it would be interesting to see if I went to the library or somewhere else.
Yeah, that's a good thing to try. But some other people have been trying to build. I don't know where they've come from. The stream or YouTube or Discord, but I don't know if they're actually using it, but they're submitting issues as they're trying to get it to build. I guess I did ask some people. And that's kind of what led to reorganizing the make file. And, I guess this is new, this whole contributing build from source doc. And building from source isn't something that a regular user would do. It's more something a developer probably would want to do. But I want to get that smoothed out. So we have build from source. There's prerequisites. You need Docker. We build a lot of dependencies. Not a lot, but under external, we build a custom Linux kernel. We build v86 with some patches. We build a version of this WASI JavaScript module. And then our shell is kind of does a build of BusyBox and some other things. And I guess some of these things are pretty complicated to build. So putting them in a container is much trouble as we're having. It's a lot less trouble than we would have trying to get this stuff to work cross-platform.
Mm-hmm.
And honestly, hard enough just getting it to run in Docker, because we're doing a lot of cross-platform things or cross-compiling.
Mm-hmm.
On different, now people are either on x86 or ARM. So you have two target platforms that you're going to run this on. And then in either case, a bunch of stuff has to be compiled to a different architecture because we only support 32-bit, or v86 only supports 32-bit stuff. So Linux and BusyBox and everything needs to be cross-compiled, which usually comes with like Go. That's just built in because it's sort of like they saw that was a common thing to do, but a lot of traditional stuff written in C, the cross-compiling tool chain is more complicated. So in some cases, especially for 32-bit, which is some people consider deprecated, the tool chains are harder to find or aren't available on certain distributions. So like that's why I'm using Debian and Ubuntu, because normally I would like to use Alpine because it's small, but some things just wouldn't build in Alpine with the packages they have. So, but for the most part, it's pretty nice because it means you have Docker installed, and then you say make deps, and it will build them all in containers. And then after that, those dependencies all produce an artifact of some kind, like Linux produces BZ image. v86 has a few. WASI, I guess, just has this one. Shell has TTC. And for people like you that can't build it in Docker for some reason, I was able to send you copies of these, or the ones that you couldn't build, and that works. Since we're embedding all of these things in the Wanix binary, we could add a hidden command to it that just lets you specify the name of a file, and it'll just write it out to disk. So that way, worst case, if you're trying to build from source and there is a release, you can download the release and then use the release to get those files, and then you can build from source from there. Let's see, I guess GitHub Actions is another very related thing, but somebody was really adamant to get CI, I think because they wanted nightly builds. I think because they are a little excited to get, I don't know if it won't build from source for them. I think their situation was something like let's see, what was it on the Wanix? Not that one. These are all, I've been closing a lot of these. Self-host. Yeah, this person is running a very custom Linux distribution, and so they don't have Docker, so they aren't able to build all the dependencies. So they've been asking about, like, can it self-host? Could you use an old release of Wanix to build the new release, which is something that you could do, and it's kind of what I'm getting at with, like, oh, you can put these dependency files in the binary of the release. But then what they've been asking for is just having GitHub build it. So I did just get that in. Every time we push, it's gonna build everything. And at least for now, this is just making sure everything does build. So that's good. Usually what CI is for is to make sure that, like, oh, you're not submitting code that breaks stuff. And I think because it builds everything from scratch, it takes like 12 minutes or something, maybe 14 minutes. But I tried to add some caching so that, like with Docker build, it'll try and cache the build. If you don't change anything and you run it again, you can kind of make that work across GitHub action runs. So it's like, oh, I've already built this, and it's like, okay, I'll cache it. But in order to make that work, it's basically exporting and importing all of the cache layers with every build. And so that takes up about half the time. So it does save time with this cache. It takes about 5 minutes, I think.
Not bad.
So that's, twice as fast as building it from scratch. But I think half of that time is just like reading and writing and loading and exporting the cache stuff. So it's a start. And GitHub Actions is always a pain to get set up because you have to make a change, push, let it run, see if it fails, then you gotta make a change, push. Like, there's not a very tight feedback loop, but it works. And one of the things actually that, if we wanted to get to today, after catching everybody up on stuff, is you can also have these builds have artifacts attached to them. So it's like, oh, the actual things that they build, you can have them kind of post onto GitHub Actions. So they're not a release, but if you go into an action, it'll have files associated with it that you could download. Which is pretty easy to set up now with this pre-built GitHub action. Let's see, download artifact. I'm trying to remember if there's like I forget what it looks like. And they don't have any screenshots, but I'm pretty sure it just looks like you go to a particular build and it'll like have the files that were built for it. And so that way, every time it builds, it also has kind of, not an official release, but like a build that you could download. So anybody could download, and we could include all the dependency artifacts as well. So that would be another way people could download the dependencies and skip building them. But also be able to get kind of like the latest build of Wanix without there being a release, which is helpful for some people. So all towards release stuff. Another minor thing that I changed now that people are actually using it is, I think the default port was like 8080 that it runs on. And I forgot that because it installs a service worker, and that service worker persists indefinitely until you go out of your way to go into DevTools and go into service workers and get rid of it, it will live there indefinitely. And so if you run something else on 8080 and you load it up in the browser, in the same browser, that service worker will still be there, and it will probably screw up whatever it is you're trying to run on 8080. So
what's the solution?
Well, I just picked the long-term solution is I actually want it to set up sort of virtual domains, so there isn't even a port, and they would not use localhost. They would use something, you could be like, I don't know, Wanix.local or something like that.
Oh, cool.
And even come up with custom names and stuff like that. And that'll be pretty cool. So in the meantime, I'm just using, while we're still on localhost, 7654 is not a very common port number that I've seen out there as a default. So going with that. Let's see. Last stream, we were starting to get into like, we can make scripts. Like, I don't know if you remember some of these. That wrap, just like simple little wrappers around the file system. APIs.
Yeah, that was just recently we were messing with those, I think.
We made one for the DOM. We made one for capabilities. And we also made one for bind. And this one's a little, even though it's nice and succinct, it's still pretty incomplete. And if you were to do this without passing arguments or, there's no usage or anything here. And normally if you were to use this command, no, let's run it somewhere back here. After all of this stuff, we run serve. So bind is pretty cool. I guess we don't have an unbind. I was testing something, so I made a little startup script. We added this so that you could specify a profile here. And so now whenever it loads up, it creates two bindings. And this is related to another thing that is a cool thing about bind that actually has never really worked. Normally in Unix or Linux, you can do these kinds of bind mounts where you're like, oh, I'm just gonna, they're like hard links. It's like, oh, instead of, it's like creating another name that points to something else, but it doesn't show up like a symlink. It's, it just you, you have no way of knowing really that it is literally pointing to something else, but usually you set it up so they're like aliases or something. But one of the neat things about the Plan 9 version is that if you were to like we have these two directories, A and B. In A, we have a file called A file. It just has some A's in it. And then in B, we have B file. And it just has some B's in it. So two directories with different files in them. And what these do is binding them to a new point, but at the same point. So it's creating a new directory C. Can you imagine what's in C?
Maybe some D's.
No, A and B. It combined them. So in C, we've got A file and B file. And they're not copies. They're literally the same thing. If we were to change A file, I don't know, lowercase a's, and then cat C A file, we get lowercase a's. So the benefit of this, and what's kind of unique to the Plan 9-ness of it, is you can create these almost layered file systems where you can be like, here's a directory, put them on top of each other. And maybe that doesn't sound useful to you, but it's kind of useful if you're like, especially if you're building up system images or, it's basically how Docker works. For example, in a Docker file, every run is basically all the steps previously gives you a base file system, and then every time you do a run, it creates an instance of Docker running up to the previous point, and then it runs this command, and that will add a bunch of files or whatever. And then after that, it will commit the difference between what happened here and what happened before into its own layer, which is pretty much just a tar file, an archive. But it only has the files that were created or added in this step. And the way it did that is it took the file system made so far, and then it makes another file system that like a read-write file system, and then it puts that new file system and sort of union mounts it on top of the old one. And so the end result is something that looks like everything up to this point, but if you write to it, those files go into the new file system. So it's sort of a weird, like, I don't know, multiplexing or like a routing, because you're like, any of the new files that you write are going to go to this new file system. And then that file system can be sort of exported into a tar or something, and it would only contain the files that were added or changed. So then when you download a built image in Docker, for example, it's like downloading all these layers. Each one of those is basically every step. So union mounting is cool. I can't think of, there's some other. For example, actually, one of the things I was able to do once I had this working was clean up how the shell works. Let's see, that would be an index. So this is part of our bootstrapping process. I mean, if we just to kind of review, when we start up Wanix, it downloads the shell. We might try and embed that or something at some point. But anyway, we set up Wanix, which is pretty much just a file system. And these sort of built-in modules like task and capability and web are initially added to the root file, or the root, what's the word? Yeah, I guess root namespace, as hidden directories. So starting with pound, which is kind of an interesting, I've never seen that before until Plan 9. And it actually seems, I don't know if it's valid for all file systems, but at least in terms of being able to use those names in a Linux shell, they do work. You just have to quote them, because if you're working with a directory, in fact, actually, could we do? Let's try. No. Will it work over here? It should. Okay, yeah. So there are all these hidden directories basically at the root, and because they're hidden, they don't show up when you list the directory. So you have to know that they're there, and it's kind of how Plan 9 works. And you can remove them if you make new namespaces, but that kind of makes them kind of like global singletons. And the way you would make them available is you would just bind them to the non-hidden name, so without the pound. So that's what's going on here. And another example of kind of layering is our shell, which we built, this shell TGZ, which looks like a little Linux system, bin, dev, lib, proc. Basically, it's what we see at the root of this environment, since it's Linux. So all the Linux stuff that we need, BusyBox, all that stuff's in there. It comes in as a tarball, which is shorthand for a gzipped tar file or archive. Tar stands for tape archive, by the way. If you're
not
curious.
know that.
Since, people used to store archives on tape. So they made a format, and it's so TARS, tape archive. Anyway, we download that. We use Go to decompress it, and we use a tar reader, which gives you an API to work with, an archive, iterate through the files. But we pass that to a tar FS, which then implements kind of a file system API on top of it. And that's cool, because then we could just throw it into our file system somewhere. Of course, we wouldn't be able to write to it, because it's kind of read from a file, and you could do a write version where maybe it writes back into the file or something, but for simplicity, it's read-only. And so because it's read-only, but we're going to be working in it and making files, what I wanted to do was bind mount it. Actually, we could try that, but when the union stuff wasn't working, instead, we get the read-only shell FS. We make an in-memory file system, which we can just read and write to. And then we copy everything in the read-only file system into this read-write one. So effectively now it has everything that was in shell, but now you can write to it. And then we bind that as shell, which isn't exactly how it should work, but like I would imagine shell would actually just be the read-only thing, and then you would set up the memory file system when you're actually using this, which we do somewhere else. So this is the WASM. This is run when everything gets started up, but it's basically setting up, all right, you have task, cap web, and we have shell as kind of another hidden thing. And then on our index, and somewhere we'll kind of consolidate these to, our index HTML should really have almost nothing in it, but we still have a bunch of stuff in it, including this kind of like boot process, which includes stuff we figured out a long time ago, like setting up the terminal and setting up the VM and wiring up together using bind. That was, another use of bind is we can say like the VM wants a file here that it's going to use for serial, and we have this other thing that we can read write to a terminal emulator, and if we bind it there, it's sort of like wiring up like a modular synth or something. And then we set up the file system that the VM is going to use, which you can see that is what we're actually using. And this is where we're actually using the union stuff, because we take dot, which in this case is root, so that's cap and web and task, and then we bind them to this file system path. So now this is a directory that pretty much contains everything that's in root as well. So it's kind of recursive, right? You could keep going file system and then go to web, VM1, file system, web, VM1. It lets you do that. But we also wanted to have all the shell stuff, all the Linux stuff mixed in. So then we just bind that shell file system to the same point, and the end result is a combination of them, right? So cap, task, web, and then all the stuff from the shell Linux one. So that's how those are. I was finally able to do this. I was doing some other trick before, and I could probably simplify the this as well, but this whole shell setup process I want to revisit at some point. Not important for our release, but just something to get out of the way. So that's cool. That the union stuff is like a really cool feature, but it hasn't been working. And it hasn't been working because there's a bunch of, there's a bug sort of deep in our file system stuff. And so I ended up having to kind of refactor and clean all that stuff up. It's kind of the nice thing about bootstrapping and building a system that is sort of built with itself, is that you're testing it, you're using it, you're dogfooding it. So the more we try and do building on top of it, and the more we try and get out of what we have, the more we are able to sort of refine and test and make sure everything works in the systems, the primitives that we've made. So that was a lot of like, another thing for whatever, one of the reasons why I had to do that refactoring was because task wasn't working. I would go ls task and it would be empty. But if I did ls task over here, you could see the stuff, and it had to do with the fact that this is sort of a dynamic file. It's different depending on who's opening it, because we're running effectively as task 1. So this returns 1. If we were running as task 2, this would return 2. And the only way you can do that is to sort of have some idea of, more information when you open the file than just what is the file name. Because normally the file system API just normally it's like, okay, what's the file system? What's the name of the file? And pretty much everything is just that. It's like, what's the file system? What's the name of the file? And you don't have any information more other than that. You don't know who's doing the operation. You don't know from where, it was made. And Go has this idea of contexts, which is kind of nice. I kind of wish every language had something like this. I mean, as a rough equivalent, React has something kind of like this, I think, called maybe context or something. But it's like in React, it's like an implicit thing. In Go, they make it explicit by you have to pass the context to every function that it's being used in. And that's a little annoying because there are a lot of things that you might want a context where you don't have it. So that's why when we did our file system kind of abstraction, we added a bunch of context versions of some of the operations, like open. So open context is just like open, but takes a context. And then we can do stuff like, and actually I can get rid of this. Because contexts let you sort of add values to them, almost key values. You can just add extra stuff. It's a kind of you don't want to go overboard, but it's an interesting way to sort of add more ways to get data into a function than just the arguments. And then in theory, if you're passing this context along to other things that take context, right, it sort of goes through the whole stack trace of calls that you're making. So, for example, with origin, we'll see if there are any. So origin in this case is like what. So for example, we do an open on a file system, and because our file systems can be composed of other file systems, the actual operation that you're going to do might not happen on the file system that you passed in, but on some other file system that's been bound, somewhere in the path of what you're trying to do. So it's taken a while for this to evolve. I don't know how much I've been showing this on streams, but almost all of the operations that you can do kind of have a structure kind of like this. So first, let's do something. Make-dir. Let's do remove. No, remove is complicated. All right, let's do chmod, which we don't use that much, but, and actually one of the things I forgot, one of the little bugs that I had to fix was, we talked about file mode. Like I explained how it's basically like an integer value that is able to encode a bunch of flags in it using bit masking, which is, a technique that isn't as popular anymore. And so it's one of those things that makes file systems feel a little old and archaic because you're dealing with like setting up bit masks. And so it's kind of a weird thing for people. But the end result is, this is literally kind of like just an integer, but it can encode a lot of information in it, like whether it's a directory, whether it's a symlink, but also the file permissions, the Unix file permissions. Read, write, execute for the owner of the group and anybody else. But it turns out chmod, and this is obvious now, usually when you chmod something, you're changing the permissions, not the entire file mode. And there was some file system that we made, I think it was our in-memory file system, where it's called chmod, and you give it a mode, and I would literally set the file mode to whatever file mode you passed it. The problem is, this isn't really supposed to be any file mode. This is really only permissions, the permission bits. Chmod is really only for setting, as far as I know, the permissions of a file, even though it's called chmod. You would think you could set any of the bits. I don't know, maybe you can't, but anyway, the point is, you can pass a permission here, and if you were to just set this, then it would replace its existing file mode, which includes information like, is this a symlink? Is this a directory? So we have to do something like this, which is really crazy. Again, bitmask stuff is really weird. But, man, what is this saying? This is saying we're doing the mode, and we're doing an AND operation on mode type, which is a bit mask that basically covers all of the non-permission stuff. And so this AND, it's kind of like a union. So I'm saying, like, I want those bits. So we're saying, okay, give me all the non-permission bits of mode, and then OR them with the mode that we passed in, but only the parts of mode that have to do with the permission bits, which we represent like this.
Ugh.
And then those are combined. Yeah. I mean, I've done this before. There is a logic to it, I swear.
But how do you know, like, the 0777? How do you know what that is?
Because you know what the permission bits are. It's hard to explain because these are in octal form. But you could think I think a way to think of it is, these are like the max values for the permissions, and so that represents all the possible values in there, and so that becomes a mask to say all the possible we need AI to explain this. I don't want to explain this stuff. I've always mostly avoided bitmask stuff. I get it. I appreciate it. But, like, I had AI write this because I was... I didn't want to work it out. Anyway, the point I was getting at chmod, though, we were talking about something else. Most of these operations now look like this. You pass in a file system, and then whatever the arguments are, usually with a name. First, we look to see if this file system implements chmod. If it does, then we'll let it do whatever that file system does for chmod. And then if it doesn't, normally we would say, okay, this file system doesn't support, this is a little helper that, oh, interesting. Oh, I guess that would come from this. So normally we would raise an error, something like not supported. And so when we try and do a chmod on this, we'd get an error. Hey, it's not supported. This file system doesn't support it. But this file system in Wanix, most of the time, initially, the thing that you're doing the operation on is going to be the namespace. But that namespace then is composed of all of these other file systems that we bind at different places. So what we want to do is get to the closest file system associated with this path. So like when we were doing, let's see, I guess in OPFS, when we were doing these bindings, for example, C, if we look at anything under C, actually all of these files are under OPFS, which is its own file system, that stores in the browser's thing. And we bind that file system at web OPFS. So now when you do anything under OPFS, it's going to have its own operations that it supports. But we might put in a path like web OPFS, A or B or whatever, and that's going to go through the namespace first. So this idea of resolving to the innermost file system is something that I've been sort of refining over the last week because it's been kind of tricky. Especially because of this binding business, we might do an operation on web OPFS CA file, and then we have to know C actually has 2 bindings associated with it, so we have to go through each of those and figure out which one of those is the right file system to use. And there's kind of a rule set with bind where it's sort of in order of the most recently added bind has precedence, and it looks for when you do a write operation, it uses the first one that it's able to write to. So there's a lot of complicated stuff going on behind the scenes, but structurally, almost all operations look like this, where we first try and do the operation on the file system. If it doesn't support it, we try and resolve to get the innermost file system. And then because that might be a different path, we get a relative name to the root of that file system. And if that resolves to something, and in this case, if it resolves to a file system that also implements chmod, then we get something back here that we can then call, and then that will call chmod on that particular file system. So this resolve system has been really important, but it's taken a while to really get it to work. Anyway, so everything kind of does that, but we also have context. If we look at task, which is a specific file system that we implemented a long time ago, as this conditional where it looks into context to see what your process ID is, and then just outputs that. But the system of resolve, the way I had it set up originally, didn't pass a context. So as it's trying to resolve to the file system closest, to the task file system, it wouldn't have a context, and so self wouldn't show up, or in some cases it would. And then it's kind of complicated because you can read the directory contents. It'll give you a list of all of the file names that are in a directory. But the way Linux works is when you do an ls, it'll do that first, but then it stats all of these. So it basically looks at the metadata for all of these. And so even if self shows up when you list the task directory, if you try and open self and it doesn't work for some reason because context wasn't passed or whatever, it'll be like, oh, this file doesn't exist. And then there's a difference between what was listed and the files that it can actually open. And so then it would show nothing. So for a long time, task just was empty on the Linux side. So anyway, all of this was related to this sort of file system resolution system and making sure that context was involved so that the resolution process can look at the context to figure out, what files exist and da 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 da. I don't know if that makes sense, but
Kind of, yes.
end result, it was like a lot of refactoring of internal stuff to get a couple of things fixed, union directories and that task. So now everything works really nicely. And that was kind of important to get out of the way because I'm trying to script out the demo that we're going to do on the 20th, day 20, which is coming up. And if the features don't work, I can't demo them. So I've just been trying to make sure that everything works that I wanted to show. But that catches us up. We're pretty close to a break. We could do an early break and then give some options of pretty easy things that we can work on. One was adding build artifacts to our GitHub Action workflow. Should be pretty straightforward, but that'll help make it easier for people that can't build the project because they can just download a most recent. What do they call them? They're not. I guess some people call them nightly builds, or the thing is they're not actually nightly. That name comes from software system. People used to have a server that would basically do a build every day automatically. So it'd be like, instead of it being on every push, it just does it every night or every day. But kind of the latest build. Not a release, but just as a development artifact. And then we have a couple of, I wanted to, capctl new should list the capabilities that we can do. We have pickrfs, we know that one. Loopback is an internal thing. WebSocket's also kind of an internal thing. So there isn't really a whole lot to show as an example of what a capability could be that you set up here. So it'd be really easy to add two. One of them would be tempfs, which is just a file system backed by in-memory. So our in-memory file system, we just register as a capability that you could create called tempfs. And then another one would be tarfs, because we do have the ability to get a file system from a tar file. We did that to use the shell tarball. And so it'd be nice to make that something that you could use from within Wanix as opposed to just if you're messing with the source. So those are two capabilities that we could add pretty easily. And then another easy thing is I started this test directory that's mostly to contain little test programs that would be compiled for WASI. So for example, this Go one, they'll all kind of look like this, but is a little Go program. It outputs what its working directory is, what arguments it got, what environment it has, what does the root file system look like. And normally that stuff is whatever, like who cares? It's just supposed to be there, but that's the point because we need to make sure that those things are accurate. So we can make these little test programs, compile them for WASI, drop them into Wanix, run them, and make sure that all of these things look right and work correctly. And then this also becomes a way to sort of test and show people hey, you can build Golang WASI stuff, and that runs in Wanix. You know, we've done a Rust one. We could add Rust one in here. But I think Zig would be a good one. I think I would like to get the attention of Zig people, or at least nod to Zig people, because I like what Zig is doing.
Yeah.
And so we just get some AI in here to say, hey, port this to Zig, because I don't know Zig that well. So we can just get some AI and have it port this to Zig. And then we'd have a little test program, which then we could say, hey, we support Zig as a language that can run in Wanix natively, quote unquote, as WASI. So
Yeah.
Why don't we take a break, a little early break, and be back at noon, I guess.
Yep. And 30 seconds.
Noon and 30 seconds. Okay.
So yeah.
BRB. Test, test. Test, test. Okay. Dara, where are you?
Okay, sorry, I'm back.
Did you get caught up with the cat?
Well, actually, I made dinner this morning, and so I was like, and I had it on the stove. I was like putting it away. So actually, not exciting at all.
Made dinner this morning.
Yeah, I always batch cook for a few days, so I'm like,
Oh, yeah.
why don't I make it in the evening? Make it in the morning.
Smart.
I like cooking, but not every day. I mean, I don't understand people that can do that. It's crazy.
I agree.
Yeah. Are you still doing your meal things?
Mm-hmm.
Nice.
I've gotten bad at making sure they give me stuff that I particularly like or want to eat diet-wise, but it's usually roughly correct. And I get sick of it a little, but I'll just, mix it up with some other things. It's just a good default.
Yeah, and I'm sure it's a lot more balanced than if you were having to like
Exactly.
eat out.
Yeah. Otherwise I wouldn't get enough vegetables, which is bad for acid reflux.
Oh shit. I didn't know you had that.
Stress and diet you can make it go away. All right. We've got 3 things we could do. We could do probably all of them in an hour. They're all pretty small, but who knows what we'll run into. Any of these stand out? I feel like build artifacts should be straightforward, and it will improve the experience for some people that are trying to get this set up or contribute or whatever. So
Seems important then.
yeah, probably more important than this other stuff, which is mostly for the demo. So yeah, let's figure out this build artifact stuff. Trench broom. So get up action. I think the way this works is you literally just add it to your workflow. Well, maybe we should read it. There's all this stuff that seems like I don't care. Improvements, breaking changes. I don't even know how it was before, so why are you starting with that? Major changes for information, blah, blah, blah. But okay, usage. I think they had some examples. So upload. We have a bunch of files, so we would use something like this.
Cool.
Compression, blah, blah, blah. I don't know. Looks like there's a lot of fancy things you can do, but I think the simple case is just this. So, and I guess let's see. I think I learned that we don't need this, so I'm going to take this out. Okay, workflow does a checkout, sets up Docker build X, which I don't totally. Solomon, the founder CEO of Docker, was really excited about the build engine of Docker. Is sort of like that was his favorite feature. This is like my least favorite feature, but I think since he left the company, he's really been as a contributor. His new startup Dagger has really been focusing on build, and they came up with this sort of new build engine that ships with Docker now. They call it Build X, and it can do a lot more things. But I've already noticed as they've sort of made it the default for some people, we have to change how some of the Docker build stuff works. Like for example, what do we like in Linux? Normally you could just say Docker build, and then we have a conditional for no caching. Ignore that, but you could say Docker build, and then T to say tag it, give it a name. So this is the name that the image will have when you build with the Docker file in the current directory. And then you would be able to say Docker run that image. But now with build X, the build doesn't get added to Docker unless you say load. So in new versions of Docker, if you don't have load, you can build this, but it won't show up, and it'll be like, if you do a Docker run, it'll be like, I don't know what that image is. How weird is that? Anyway, weird evolution of already weird software. But anyway, Docker X, I don't know what this action does, but it sets it up. This GitHub action is for setting up caching. And basically all this does is sets up a directory that if there is a stored cache, it sort of puts all of it into this place. So when we run, we have access to, cached files from previous runs or whatever. And then at the end, anything that's changed here is persisted for the next time. And there's some stuff here about keys for doing like different caches for different OSs and different branches and stuff. So this sets up that. Then we do all of our dependency builds using this weird build push action. Anyway, this was all written by AI, of course. And of course, I was really hoping, I've never had a lot of luck having like a GitHub action workflow work the first time, because you always forget something, or it works a little bit differently than you thought, or whatever. This halfway through the build, you realize you need this or something. So I thought maybe for the first time, I'd have like a working workflow on the first try, because I used AI and AI knows what it's doing. But nope. Took a bunch of iterations. But I guess this is how you would do a Docker build using Docker build X that will then cache to a particular place, in this case, the cache directory that we set up. So this is, instead of just doing a normal Docker build, by using this GitHub action, it will do the Docker build, but it will also write all of its cache layers to this directory. So anyway, that's what these are doing. Building dependencies with Docker, then build the shell, then we gotta move the cache because we were reading from the cache from before, and then we made a new cache that we want to now save. So then we move that, replace the cache directory with the new cache. And then at the end of this, Docker GitHub Actions will save this directory. Then we set up Go, then we set up TinyGo, and then we can do make build.
Nice.
And then after make build, we can try and do this upload artifact thing. Name. Does name matter? What is this supposed to be? Outputs. Optional. Okay, cool. Well, if it's optional. Default is artifact. All right, fine, whatever. Path. So we have multiple things that we want to keep around. Presumably, we're in the project root. So one would be Wanix. That would be the executable. What else? And then our dependencies. So we have external Linux BZ image. We have a bunch of stuff under v86. v86 lib v86.js. I've been a little frustrated with Cursor recently because its autocomplete, its AI autocomplete will be incorrect. So you know how there's normally like autocomplete just IntelliSense or whatever, like it knows you're like, what methods does this have, and it lists them, and then you can autocomplete or whatever arguments or whatever. And so like that autocomplete is great because it's always accurate, well, most of the time, because it's literally just reading the APIs and being like, hey, these are your options. But then the AI autocomplete is not bound by that. So it'll suggest all kinds of stuff, and it's supposed to be smart, intelligent, but sometimes it's something that doesn't make sense. So that's an interesting thing, that there's these competing autocompletes with this Copilot kind of interface.
Mm-hmm.
C BIOS. v86 is a bunch of files. VGA BIOS. See, that's correct. External WASI. Okay, no, that's not correct. And so this is what bugs me, is it'll be like very close to correct, except it got one thing very wrong. And it's like, why did it get that wrong? WASI.wasm does not exist in here. So why would you think that's what I wanted, you know? It's, you know, obviously this is basically hallucinations that everybody talks about, but it's just kind of a weird, like I didn't think that would happen in this context. So maybe we blame Cursor. Maybe we blame the fact that I just have not been updating Cursor, and maybe it's way better because I haven't updated. And then shell. I think that's all, although we might also want to do the WASM that we build, because we have the Wanix executable, but the thing that we're loading on the page is the Wanix WASM, which we embed in the executable. And that's why we use both TinyGo and Go. And even though it's in the executable, we might as well just include it as an artifact. WASM.
Might as well.
It's a thing that's built, so Wanix.wasm. Well, that's a lot. Hopefully that's all we have to do. What are these other things here? Okay, minor things. How would I never know. Let's see. White space and actually I think that was a add white space, but whatever. I hate having to write a message for something so trivial, but you're sort of forced into it using Git. Okay, so this is GitHub, and we're adding upload artifact. I guess it's an action. And then we get to, let me rebase on main. This is the other thing that makes it difficult to debug these things. You have to use git a bunch. Git push. I think I've been force pushing to 0.3. 0.3, so originally we were doing all of this work in the 0.3 branch, and then recently I basically merged it all into main, but I'm still pushing to 0.3 and then doing pull requests into main, and then that helps document. Plus I added a policy, so you couldn't push directly to main if you wanted, but usually you would, push to a new branch for every little thing, but I keep reusing 0.3 because it makes sense. This is all kind of part of 0.3 development. But because I've never done this workflow before where push to 0.3, because we're constantly rebasing against main, we're sort of forced to force push to 0.3. So some people, if anybody else is using 0.3, they might not like that, because force pushing basically forces you to rebase and, potentially creates all kinds of problems. But I feel like it's kind of safe to do here, because it's not like a real branch. It's kind of like a work branch, and nobody else is really pushing into it except us. So, okay, so just pushing to 0.3 should trigger a build. Yep. And so, I don't know. We'll see how this goes. Looks like caching works. Cached. But then it has to write all the layers that was made during the build. It has to export them out of Docker, compress them, whatever, export them, write them, put them in a tarball, and then put them in the... And then because we're going to use them, then it has to import them back into Docker. Like, this whole new build X thing is so weird. But it's like this takes longer than our build. Just writing and reading all these layers. So anyway, this has to run. Yeah. This will be like, I mean, if it weren't for all this caching stuff, It'd be a lot quicker. So in the meantime, why don't we move on to one of these? Any of these appeal more? Do you want to write some Zig?
I want to watch you write some Zig.
You're going to watch me watch AI write Zig.
Well,
That sound fun?
I guess I am watching you watch if I'm looking at your screen, in a sense.
Yeah. Let's see. All right. Rewrite this in Zig. Of course, allocators, it's Zig. FYI, Zig requires explicit memory management, unlike Go, where it's memory managed. Error handling is explicit with try and return. I don't know how I feel about. It's not exactly like exception handling, but I don't know. Everybody's trying to find better ways to do error handling because everybody's like, Go's is so stupid. I'm like, that's fine. What the fuck is wrong with it?
I mean, we've talked about this a little bit. Go is not perfect.
That's I have a hard time saying yes. I mean, it's not perfect, but it's like nothing is perfect. The whole point, though, is that its design constraints make sense for, the goals. Everything's trade-offs.
Yep.
And my values are aligned with the way Go does things. So
it's kind of like a religion, do you think?
Yeah.
People's
I mean, that's
coding languages.
Yeah. People have compared programming languages to religions for decades.
Oh.
Okay. Well, I'm gonna copy it. Well, why don't? Can you put this in test.wazzy Zig and write a make file that will build it for WASI. And I'll do this code base one so it can look at more files than just main. So it's like, okay, I'll do this. I guess I have to apply these. Obviously, I want to apply it here. Okay, that's pretty good. And then a make file. I don't know why it would think to put it there, but and then a get ignore. Very good. Yep, it's very similar to the Go one. All right, so I guess that's like femit, f-emit. WASM32 WASI. And I'm pretty sure I have Zig installed. So we could try make Womp womp. It gave us bad code. Bad.
Mm-hmm.
Alright, do this. Here, not the make file. This file. Why isn't it adding this context properly? In here. What the hell? Wait. Yeah, main.sig. Fix. I feel like I got this last time. Claude is not great at writing Zig yet, but that makes sense. It's a new language.
How new?
I mean, it's not 1.0 yet, and languages, especially one that's made by one person and not a company, takes a while to bake. I mean, there's a community now, but it's sort of like been around for a long time, but in a very early state. It's still in a pretty early state, enough that some people are like, I don't know if I want to use it because it's not 1.0 yet. But that's how new it is, even though it's still been a few years now at this point. Why don't we have syntax highlighting for Zig? All right, let's try to build again. Oh, God.
You need to add an extension or something.
Yeah, probably. So here's the thing. Real path. What the hell? So different languages sort of have different levels of support for WASI. Real path, which is kind of a common name for, I think it's maybe in libc, but a common sort of system function that, like, kind of in a way resolves a path, checks to see if it's, if you're referring to a path and you're in a current working directory and the path is relative, that it will, join it with your working directory. If it's a symlink, it'll resolve it. So, but anyway, I guess it's like, oh, hey, working with the file system, that doesn't happen in WASM. So this might be a Zig thing. And I'm pretty sure Claude will not be able to figure that out. So it's possible that we will not do that until we figure out what we're supposed to do. Oh, I can't even comment it out. It has no idea what Zig is. Should I install a Zig thing? There are a couple. Obviously, this one is more popular, but who knows? There was I think it was a VS Code extension. It was like a theme or something that had some malware in it. Pretty crazy.
Oh, shit.
Yeah, people don't realize it is
Like something you could get through this official store.
Pretty sure.
That's kind of scary.
Yeah.
I would think you could trust all that stuff.
Right. I mean, in a way you can, just based on like numbers and like how long it's been around and like, blah, blah, blah. But I don't know. You heard about that. I guess you'd call it like a supply chain attack where someone was like, they found a project that was not super actively maintained, and they started contributing to it, like actually doing like good contributions. And then I think they might have even became a maintainer, but then they pushed something that added a backdoor or something. I'm trying to remember.
I did,
Yeah,
yeah.
that was a big story.
Yeah.
All right. So, yeah. Oh, great. Gotta always just double check everything, you know, just to be safe. It's usually okay, but we'll just do not available. Now what? Oh, I did something wrong here. Expected 2 arguments. Why is it expecting 2 arguments? Okay, just empty thing. Okay, well that worked. We made a zig thing. We can try it out, but let's go back and check on our build that succeeded. And then somewhere at the bottom, post checkout, post, upload artifact. Least common ancestor, that will be the root directory. Artifact name is valid. Looks like it's all good. Download URL. Okay, I guess it put them all in a zip file. And then I thought it like made it so that in the UI there was some way to... Okay, yeah, artifacts. Okay, well, so even though it supports multiple artifacts, it's just putting them all in a zip file. And then it also looks like it's naming that file based on the name that we gave this, which we didn't. So it's just called artifact. Maybe a Wanix build.zip would be a good name if that's what it's going to do. But let's check it out. BZ image, all of those. Yep. Yeah, it looks like that's everything. So that's cool. So now if you ever have trouble with build deps, you can just grab the latest Linux and shell files from GitHub Actions. Although these will be built for Linux, and so that's maybe something for the future, is having it cross-compile and almost do everything that we would do for a release and do all the different all the different platforms that we support. And then, I don't know. We'll figure that out later. I think this is a good step in that direction. But I would like to hopefully make that file name. Nope. Git and GitHub. that's going to build, and we'll see how that goes. But I think it's pretty much working. Yeah, this is pretty nice to have. We'll say that's done. Okay, Zig test. We need to run Wanix. And let's see, reveal in Finder. Zig.wasm, and then reload this. And then we should be able to drop this file in. Then it should be in OPFS. And by default, it has the execute bit because everything does in OPFS right now. So in theory, we should be able to just run it. Whoa! At least it ran. So it's a start.
Nice. Well, what's denying you access?
Well, I don't know. Probably just the fact that Zig's runtime is like, oh, you're building for WASM? You don't have a root file system. Or something. You know, they haven't finished supporting WASI Preview 1 or something. I don't know. We'd have to look into it. I just assumed, because a lot of languages have been pretty good at that, and Zig being like a new language, even though it's like, oh, maybe they're not there yet, I would have thought that the early community would be excited to do this stuff. But at least it runs. Like it's running a Zig WASI executable, and that's pretty cool.
Yeah.
Although I wish it was doing environment on new lines, and it would be good to know to look into this and this. But that's... I do want new lines to it, though. Let's do new lines. Environment, print. How about that? I think in theory, we could just drop this in and it'll overwrite it. Cool. That's not a terrible workflow. Okay, though now I'm like, oh, but now we need a new line there for consistency. What else do we need? I guess everything else is adequate. I wish these were aligned, but I don't know how to do that in Zig, and I don't trust AI to do it. So let's just try this. Cool. It looks better. Yeah. Anyway, okay. Well, that's Zig. We did it.
Boom. Done.
Okay, and then we want to commit it, but let's see if... I don't know why get ignore didn't ignore that O file that it made. Zig.wasm.o. Yeah, so we're just versioning this and this. The other make files, I've been adding a clobber. Which is a funny name, but it's sort of like a more aggressive clean where it will get rid of the files that are generated or whatever. Try and reset it to a state as if you just checked it out. And I've been doing that everywhere else, so maybe we should do it here too. Wait, this is the Golang one. So yeah, Golang, that's pretty simple. And then here, not just that, but it also made .o. I guess that's it. It didn't make anything else, so. And they're gone. Cool. How do I want to prefix it? Golang, I guess. My prefixes are usually the directory that you're making changes in, because if you're making small enough changes, they're usually specific to a particular part of the code base, and so it's sort of specific to a directory. And then this makes it a little bit easier to see going through commits, like, you know, it's descriptive in that it's saying what area of code you're working on. Oh, Golang, the Golang directory. But sometimes if it's across multiple things, I used to do multiple things, but now I'll just come up with something that makes sense, even if it's not a directory. Like, I don't know, something just like a common keyword.
Yeah, like a
feature,
like a tag or something.
Yeah, like you might name a branch name or something. Yeah. Add clobber. Add zig. Test. Okay. Is this the right one? Yes. What else? We got 15 minutes. Tampa Fest will be easy. Let's knock that out.
All right.
Capability. I guess where would it live? I mean, it's based on memfs, which is assumed we always have it. So maybe this is a built-in one. Just like loopback, I guess, is a... Wait, what? Allocator. Oh yeah, I made this more complicated. I guess this is where I would define new. Let's see. New, it's going over allocators. Allocators. Okay, so we could add something. How does this work? Get past a resource and then a mounter, which is the thing that returns the file system. So this is set up so that it's called an allocator, because when you do new, it's not actually mounting anything, but it sets up the directory and everything. And now you can do things during that allocation step, and then it returns a function that will be run when you actually do the mount, passing any arguments. So it's kind of like a two-step thing that we're defining here by having it return effectively a function. Fancy programmer stuff. I basically just want to... I don't think... Do we have a new... Oh, we do. Wait. Oh, yeah. It's just a map. So we can just say memfs. fskit memfs. As easy as that, I think. Let's go check it out. We can use our capctl tempfs. Look at that. New tempfs. All right, so now we have it allocated, and then we do a mount. All right, so now there's a mount, and then this is an in-memory file system that we could put files in. Make directories. But obviously it will disappear when we reload the page. And then we could use bind to put it somewhere, like, I don't know, maybe we'll put it in the root. Cap1 mount memfs. There's memfs. There's our stuff. So that's done.
Damn.
Easy.
That was literally like 5 minutes.
It's like the perfect feature ad. TarFS, man, could we get that done in 10 minutes? The thing is, this is one that would take an argument, like what tar file? And then is this a tar file in the local file system, or does it need to fetch it? The cool thing is that once we do this, we can kind of replace this kind of ugliness because it'll be part of a capability, and then we could just kind of do capability stuff through the file system. So in a way, we're kind of refactoring this into a general thing. I guess this would be probably built in as well. TarFS. Okay, pretty close. So we can pass arguments to mount, and we could... One thing I haven't figured out is how do you know the difference of whether you're referring to something on the file system or a path on this domain, or, you know, obviously if it's a URL, it'll start with HTTP or something, but this is why people came up with this file : scheme to say, I'm referring to a file, not something else. I mean, we could do that. We could use that scheme. We haven't used it anywhere else. What do you think?
I mean, it always seems good to use conventions that people are familiar with.
Yeah.
I can't think of anything better.
It's just that this is the only place we're using this convention to refer to a file, but it's also one of the only places where we have this ambiguity. So yeah, let's try it.
I mean, is there a reason we couldn't use it other places too? Even if it's not necessary.
Right. Well, that's I mean, certain things are very much sort of like assuming Linux convention or, Unixy conventions, like, like our bind command or, these things. Like, it would be a lot more work to like strip off. I don't know. We'll worry about it later. I don't remember what our arguments are. Also, I'm curious what happens when you do return an error. Hello, error. And then let's print out args, because I don't remember if mount is going to be included in these args or if I pull it out before passing it. No, that's fine. Just let me use it that way. Capctl new tarfs. And in theory, we can do this. ABC. All right, so it's just the arguments to mount, and we don't get an error here, but at least the error shows up here. Okay, so first argument, or I guess we would want to say if we don't have arguments, we'd say something like that. And then URL parse arg0 u error. Because this should, I'm pretty sure, support the file thing. And look, somehow, I don't know, is it because I wrote it out somewhere, or if it just knows where we're going with this? Although it's not, if it was HTTPS, let's see. What do we want to support first? Like, I think too, if we just passed something like this, then it should assume it's HTTP. Relative to this host. So like, nope. What are you doing? View scheme. Why? I just don't. I feel like it's gotten worse. It doesn't help that all these models are constantly being updated.
Yeah.
If scheme is empty, then not file, but we kind of need, I guess we'll assume HTTPS for now, because no, we can't do that because we're not doing it over HTTPS right now. Okay, this should use whatever the current scheme is on the page. And then not this. So all this is to figure out, now maybe we do like a switch based on the scheme. case would be file, and then we should have a default, and we could have I want to autocomplete, but it's just not giving me anything good. Get out of here. Invalid. Unsupported scheme. God, get out of here. Unsupported scheme. There's no error. It's just stop it. In the case of this, we actually want to use. Oh, I guess this is gonna depend on whether we're in a browser or not. Let's see, because we're short on time, let's not do file. And then we'll just, for now, just basically do this. I'm sure there's a cleaner way to do this, but where would we put this? Okay, so the promise, and then we get back a response whether the request succeeded or failed. Oh, this is gonna be annoying because this is a JavaScript specific API. I know, we can put this in a separate file. Call it tarfs WASM JS. We'll do JS. In theory, this will imply a build tag that it will only build when we're building for WASM, but we will do an explicit version of that. As well. And we'll make, what is this? Fetch. Actually, yeah, maybe it's just a fetch. It's not even specific to tar.
What you thinking about timing? Because I'm getting hungry.
Oh, it'll all come together. Oh, it's already one. Let me think. 5 minutes? Can you do that?
Fine. I'm gonna go get a little Kit Kat though.
All right. We'll just do most of this in here. And ultimately, though, we're getting... Do you need to use the fetch API directly? If not, could it work for you to use, which is higher level and uses fetch under the hood for you? It could. Well, good question. It should use fetch under the hood, but I don't know that it does. But, let's try it. Because it would kind of be duplicating. Yeah, let's do that. And I'll kind of keep this as like a backup. That doesn't work. Yeah, do the fetch. I never use the high level get, but why not? Is it Starfield? Yeah, it is. Body close. Do we want to do this from here? Why not? Reader. Load. Yeah, if this works, yeah, we'll have saved some good time, and I appreciate the suggestion. Welcome, by the way. Let's see, is this it? That's all we gotta do. I got a nice suggestion in chat while you were gone.
Oh, I wasn't gone. I was just muted because I was eating my Kit Kat.
But in theory, Go will implement the built-in HTTP GET with a fetch when it's compiled to JavaScript or WASM. I think I'm confused. Well, that might not be the case if your target is WASI instead of the regular JavaScript WASM. But I don't know. We'll see. We'll try this because this is a lot shorter. Okay, let's try it, I guess. 1 minute to go. Cap CTL new TARFS cap CTL 1 mount, and we'll give it a path. Basically, give it the same thing as what we're doing here, which is boop. Resulted in a network error response. The promise was rejected. And the promise was rejected because it tried to, okay, it doesn't know. Like if we're using Go, it's not going to default add the host name, the current host name, I guess. But it should work if we do, so let's try doing that. And then maybe it'll be done and we'll be out of here. TARFS. No errors or anything. Oh, broken. Oh well. That's it. We failed.
I mean,
we're out of
just
time.
temporarily.
Yeah.
It could be a cliffhanger for the next stream.
That's true. we all know it'll be
saying
it'll
people love
it'll be done by
cliffhangers.
then.
Yeah, I know you can't handle waiting.
But okay, cool. We did a bunch of stuff today. I'll commit after this. I'll probably keep going just until this works, and then
I bet
commit
you
that.
will.
But I guess that's it for today, which means that's it for this week. And the next Wanix stream normally would be on Monday. Oh yeah, Monday was a holiday this week too. But next Monday should be fine. So that would mean
I can't do next Monday, unfortunately.
Ooh, okay, well that's good. It gives us more time. That would
That's
put
nice.
that
Nice
would
way to
put
think about it.
yeah, that would put the final stream on the next Monday or Wednesday. So a couple weeks
Cool.
left. Although if you're watching on YouTube, these are delayed. They're coming out like 3 days apart. So anyway, that's it for today. Thanks everybody for hanging out. Thank you.
Great work.
Demitcher. How would you say that?
Demitcher.
Thanks for the suggestion. Yeah, that's it. See ya,
Alrighty, bye,
everybody.
people.
Bye.